now move on to our next session. I would like to welcome our next speaker, Mr. Suresh Basavraju. So I would like to brief about his profile. He is working as a technical lead in Verifone, Bangalore, India. He is a Bachelor of Computer Applications, Bangalore University. He is Masters in Science, Information Technology, Karnataka State Open University, Mysuru, and over 10 plus years of IT experience, which includes DevOps tools, OpenShift container, Layer 7 service gateway, Kong API gateway, Linux, proficient with Shell, Ansible Groovy scripting languages, and all. And he is also has an extensive experience in architecting, designing, and implementation of fully automated continuous integration, continuous delivery, continuous deployment pipelines using DevOps tools. And he is also focusing on continuous improvements and identifying best practices and automation effort. So I would like to welcome you, sir. Over to you, sir.
Yeah, thank you, Tara. Thank you very much.
Thank you, sir.
Yeah, so I'll share my screen and I'll start off with my presentation. Okay.
Sure.
So today I'll be talking about a few of the latest technologies, like how Hotstar, Netflix,
Sorry
and
to interrupt you, sir.
yeah.
Sir, your screen is not visible.
Yes, I haven't
Would you
shared
please
it.
share? Yeah, please share your screen, sir.
Yes.
And your video is off, sir. Kindly switch on your video.
Okay. Are you able to see my screen now?
Yes, sir. Now it's visible. It's visible, sir.
Okay. Are you able to see my
Yes.
video as well? Okay.
Yes, audio is. Both are fine, sir. Audio and video, both are fine. You may go
Okay.
ahead, sir.
Sure. I'll be turning off my video because of my bandwidth issues. Okay. So I'll proceed with my presentation and then we can go on with the question and answers. Okay.
Sure.
So, yeah. So today I'll be explaining about the latest technologies like our mobile applications like Hotstar, Netflix, and as well as Amazon Prime videos. How do they stream the videos, and a bit of use cases about how our Uber application tracks your cabs moving in and out. Okay. Okay, so let's proceed with the presentation. Okay. Okay, so what is an event? Okay, so event in a real world, it's like something happened. In IT world, it's like a small event that happens to your electronic devices. Okay, so it may be a tweet, a sale, a trade, and an invoice. And you can see a small picture onto the right side how the cab tracking is going on in your mobile app. Okay, so this occurrence is happening at a determinable time and place without with or without participations of human agent. Okay. All right. So these are the data which is coming into the Kafka. So these are the data sources. Okay. So if you see on the left side, we can see the cars which is connected to the internet, financial transactions, hospitals, logistics and shipping, and you can see insurance, e-commerce, mobility, and manufacturer assemblies as well. So all these are like electronic devices are connected to each other, and the customers are getting updated every now and then, right? So I want to show like how the world produces data into a system, and how do we manage it and provide an update to the customer. okay? Because if we do a transaction financially, so we will be waiting for acknowledgement, like whether our financial transaction is successful or not, right? And if you take a connected car, and you'll be very eager to know where my cab is arriving. Is it arriving at a time? Are we reaching at the destination at the right time? So this shows us how our systems are connected and how we can progress forward and making a real-time decision on it. Okay, and if you consider logistic shipping, you can see our transactions or our logistics are where it is reaching and what is the status of this logistic, where it is seen. The customers will be very eager to know about it, right? So today I'm going to explain a little bit of this and how do we manage the data in Kafka. Okay, as most of you don't know what is Kafka, so what is this Kafka is? So I want to just briefly explain about it. So Kafka is a foundation of what we call it as distributed streaming platform used for building real-time data pipelines and streaming apps. Okay, so this is horizontally scalable, highly fault tolerant, wicked fast, and runs in productions by thousands of companies. Okay, and if you want to go more deep into it, what's a streaming platform? Okay, streaming platform has three keys capabilities. Okay, so if you see publish and subscribes of stream, so if you take an example of Amazon or a Netflix, so Amazon will be publishing data and through Prime Videos, and we subscribe them, and we can see the streaming data on our mobile devices or our electronic devices, right? So this is called publish and subscribe model. Okay, so this is a stream of records which is coming into the message queue or an enterprise messaging system. Okay, and we store the data in Apache Kafka. All right, and you can see the pen, right? So this is the place where we store and process it on the real time. Okay, so and Kafka is generally used in two broad classes, two broad classes of applications like real-time streaming and where we rely on data between systems or applications. So this is the data between the systems and the applications. Okay, and the next thing is we transform the data from one format to other to transform from one kind of a software to another kind of a software, right? And let's go to the next. So how do we produce data? Okay, so to understand Kafka as a streaming platform, it is very important that we first discuss few basics. One central element that enables Kafka and streaming processing is called log. So here on the diagram, if you see a small box which is highlighted in orange color, is called a log. Log, it's the context, of Kafka. It's also called as commit log. Okay, so basically you may not be understanding what log is. So a log is a data structure that is like a stack of elements where new elements are always appended uh, at the end of the stack, and once written, they never change. Okay, in this regard. Okay, so this is like an append only, write once data structure. Okay. Uh, Hi Tara. So few people have raised their hands. Should we interrupt and answer the questions? Hello.
Suresh sir, we can answer it at the end of the session. You can continue
Okay.
with the slides, sir.
Sure. Thank you very much. Okay. All right. So we were talking about data structure. So this is a write once data structure. So elements that are added to the log are strictly ordered in time. So first element added to the stack is older than the second one, which is in turn is older than the third one. Okay. In the image, the time axis reflects that fact the index of elements in that sense can be viewed on the time scale, right? So let's go to the next one. All right. So how this log structure data flow? Okay, the log is produced by some data source. In the image, the data source has already produced element of 0 to 10. Okay, say suppose just 0 to 10, for example. Okay, and the next element source produced will be written at index 11, so that you can see here. Okay. The data source can write at its own speed since it's totally decoupled from any destination system. So what you're saying is it produced the data into the topic or the data structure, but it did not wait for the consumer to consume the data. So it keeps on posting it. That means it is decoupling the producers and consumers, right? Okay. Uh, the data source can write at its own speed since it's totally decoupled from any destination system. In fact, the source system does not know anything about the consuming, right? So the producers will be producing and the consumers will be consuming at their own speed, okay? In this sample diagram, we have 3 consumers and 1 producers. This is totally fine and its expected behavior here. So here you can see the consumer 1 is reading from the 15th log and the consumer 2 is reading from the maybe seventh log, right? So here each destination system consumes the element from the log in temporal order. That is a form of left to right in our image, right? Okay, go to the next session slide. Okay. So in our last slide, you saw how the log messages is going into the data structure, okay? So now for a reliability reason, one wants to keep around more than 1 copy of these log messages. Why this log replication is to have high availability. Say, suppose you're streaming a video on your mobile app, and say if you see a glitch in your video, you may not feel interesting, right? Or you may lose interest on the video, or you may lose interest on the application itself, right? So what these application teams or the companies do is they rely on making 1 or more copy of this data. This process is called replication. Okay, so with a log, this is straightforward to implement. Okay, one possible way of doing a log replication is we have a single leader and the followers will follow. That means it reads the data and makes a copy by itself. Okay, right. So the followers read the data from leader's log and update their own logical log accordingly as shown in the image, right? The followers whose log is up to date is called in sync replica. That means it is following the leader, so it is in sync with the leader. Say suppose if it fails to read and write it to its own log, it's called out of sync. Okay, this is a basic general concept in most of our distributed systems and messaging. Okay, so after this so long talk, everybody will have a question. Why Kafka? Why not something else, right? So Apache Kafka is a freeware, okay? And it is totally stable, provides reliability, durability, has flexible publish subscribe model that scales with n number of consumers and has robust replication of data. That means it is highly available, right? And it provides producers with tunable consistencies, guarantees of message being delivered to the end system, and it provides preserved ordering at a sharding level. It's called Kafka topic and partitions. And as I showed in the slide, it is highly, it's higher throughput. You can manage like 50,000 to 60,000 data messages per second. Okay, and it can process up to like 4 commas in your number series. Yeah, and it's highly very easy to operationalize and use it. Okay, let's go forward and see more about what is this Apache Kafka. Okay, so as we saw, each and every electronic devices in our world is connected. It has its own applications, and it established connections to these electronic devices and produce data to Kafka. Okay, so if you see the data once produced to Kafka, you are expecting acknowledgements, right? So now when a produce the data to Kafka, and Kafka says to the producer says like, my messages which is sent to Kafka is safe or not, right? And Kafka replies saying, your messages are safe with me, and you can go and look for new messages and then send it to me, right? This is how the electronic devices are connected to the system. Okay. Now, this is an interesting part. Now, producer sends data to the Kafka. Okay, Kafka has its own brokers, it's called. Okay, so how do you manage these data chunks which is coming from various sources, right? You need a pretty good hardware to store this data, right? So producers send messages to brokers, brokers receive it and stores the messages. Okay, and in this it's a Kafka cluster, right? So we have n number of brokers in this. So brokers is constitute to a server, a physical server or a virtual server. Okay, and we have a retention time. Say here Kafka does not store the data permanently. It has a retention time. The data stored for a certain period of time, right? And it stores on the local storage of the system, right? This is basically, it helps in faster processing. Okay. So let's go to the next slide. Okay, so this is the consumers. So as you saw, the producers produce to brokers and they forget about the message, right? And the data is stored in the Kafka brokers. Now it's the work of Kafka consumer. So we have the raw data stored in Kafka, large number of data, right? And now how consumers consume the data. So we poll the data and we get the data records. Okay, and once we get the data records, for many people it's like reporting via dashboards, and we get insights, and later we can process the data as well, right? So this is how the consumers pulls the data and get it. Okay, and it will be reporting. So you have poll intervals, and you can pull that, get the data in batch size as well. Batch size, batch number count, number of messages per batch. There's so many other things that you can do, right? And here in this diagram, say consumers pull the message from 1 to n topics. New inflow messages are automatically retrieved, and the consumers will help the brokers to keep track of the messages last read, right? Say, suppose while I'm reading the messages from the broker, say the consumer died, okay? The data is still there in the brokers. So as and when the consumer come up, it need not read from the beginning, right? It can read from where it left out, okay? So this is called offset management. Okay, that in detail we can go through in the next slide. Okay, right. As we understood more about producers and consumers, so here we will talk about decoupling of producers and consumers. So this slide basically says the producers and consumers are not dependent. Okay, they are independent. Okay, so they are decoupled. So say suppose the producers are faster in producing the data and consumers are slow in consuming the data. The the effect of producers, I mean, performance are not affected by this, okay? Because the data is stored in Kafka brokers for a certain period of time. So the producers or the consumers, they don't depend on each other, okay? And as I explained earlier, so the failure of the consumers do not affect the system, okay? So we can see that 100% guarantee of the message is being produced and consumed, okay? So let's see the architecture of the Kafka, okay? So here you have a number of producers in here, which writes data to Kafka broker, okay? The brokers are the servers, and here we have a new component called Zookeeper, which manages, it basically manages the servers, okay? So here we'll have huge amount of data, and it does not know how to manage it, right? So Zookeeper is just like our uh, uh, just like our watchman, I can say, who watches these brokers and manages it for highly available of these data on the system, okay? Once these highly available data is available for the consumer, the consumers will read the data from there, okay? All right, so let's go to the next slide. I know there are so many questions arising. Yeah, we can discuss about it at the end of the session, okay? All right, so as you know, the data is being coming in. So where this data is stored, how the producers send the data to the particular consumer, right? How can it send the data to the particular or specific kind of topic, right? So in the stream related, mm, uh, okay, so basically these topics are logically separated, okay, logical representation, characterizing the messages into group, right? So as when the developers is developing this application, they define the topic for its particular functionality or a feature, okay? And you can see there is end-to-end relationship between the producer and consumer. There can be unlimited number of these kind of relationship between the producers and consumer, okay? Let's go to the next. This is very interesting. Okay, so this is the data how is stored on the brokers, okay? So let me explain what is topic. Okay, topic comprises all the messages of a given category. Okay, so we have the topic which would contain all the messages that can be contained on the transaction of a particular type of data. Okay, say suppose Uber is tracking the status of the cab. So in the topic A, he may be getting the Google location of the cab, okay? And topic B may be the driver details, and topic C where the consumer or the passenger data can be on topic C. This is just an example, okay? So this for each type of entity in the application can be termed as a topic, and this topic can contain the data for the specific event, okay? And each topic has multiple partitions, okay? So why partition? What is this partition, right? So if you say Uber or the Netflix, there's so many consumers consuming it. How to manage this bottlenecks, right? If I have one topic and one partition, it'll be overloaded, right? In this kind of a strength of the population, right? Number of consumers, it's very difficult to manage. So the partition enables parallelism, okay, to parallelize work and thus increase the throughput of data, okay? And topics are split into many partitions. The message of the topic will then be split between the partitions, okay? Here, there's a default algorithm that is used to decide to which partition the message has to go. Basically, it uses hash code of the message key, okay? And a partition can be viewed as a log. Okay, so once this partition is shown, okay, there's another thing called segments. Okay, the broker stores the message as they come in a physical files, right? Since the data can potentially be fragmented, is using these rolling strategies to store the data. It creates and allocates a new file and fills it with messages. Okay, when the segment is full, the given time per segment expires, the next one will be allocated directly. Okay, so this is how the data is stored on the physical hardware. So as and when I show it in practical, we can go and dig into this, right? Okay. Okay, let's go to the next. So this is more in-depth to our previous slide. Normally, one uses several Kafka brokers that forms a cluster to scale out. If we have three topics, that is three categories of messages, then they may be organized physically as shown in this picture, right? A partition of each topic are distributed among the brokers. You can see the partition 0, it's all there in all the brokers, okay? So this is basically a replication of the data from one broker to the other broker. And you can see the segments are treated as a rolling file strategy. Kafka opens the file, allocates on the disk, and then fills the file sequentially with the data, okay? And depends on the max size of the file and what's the time that is going to be expired, okay? Subsequently, as and when the data gets in, so it starts creating multiple files for these new messages, okay? All right, so let's go to the next slide. This is the important stuff, replicating. So this is basically for high availability and parallelism, okay? So the data in this are replicated to one another, okay? So far, we have said that each broker manages one or more partitions for a topic. This does not provide reliability, right? A broker failing would result in all those partitions being unavailable, right? Here. Right? So Kafka takes care of this by replicating the data of each partition, okay? The replication factor is configurable, okay? So you can configure, depends on the developer or the application owner, what he decides, okay? So Kafka maintains replication of each partition on another broker in the cluster. One replica is in the role of the leader, say partition 0 in here is the leader, and partition 0 is replication, is a follower, which is highlighted in green, right? So often we refer to the broker that holds the data is the leader and replica for a particular partition as the follower, okay? And the broker that holds the replicated data is also called as follower, okay? All right, so let's go to the next one. Now we have talked about topics, partitions, and segments. We need to have a word about the entities that produce the data and consume it, right? Producers, you see, these are the producers here. These are the application that write data to one-to-many topics. As I said in earlier, it can have end-to-end relationship, right? The consumers and the consumer groups are organized in consumers are organized in consumer group, okay? The members of a consumer group collaborate with each other and such allow parallel processing of the data, okay? The consumers in the consumer group are the instance of the same application, okay? Say suppose producers send 10 messages in here, uh, say the same 5 messages is consumed by this instance of the application, and you can see the data being replicated in here. The consumer of the second instance consumes the data from the other partition in the broker, okay? So basically this allows more of parallelism and high performance applications, right? And the data which is read in consumer one cannot be read in consumer 2, right? So this avoids deduplication, okay? The duplication of the data, okay? So you don't have to run deduplicate command again to have a unique data, right? Producers and consumers are both called Kafka clients. At a high level, Kafka is a pub sub messaging system that produces that captures event. Event are sent to and stored locally on the central cluster of the broker, and the consumers subscribe to the particular topic or the named category of data. Okay, and producers to consumer data flow is in at the real time. Okay, so it's not at the batches side, it's not at the particular time, so it's on the real time. Okay, all right, so let's get into the log part. What is the data element in here? So as we discuss about the message, right? Message are termed as commit logs. Inside the log, how does it look, right? So it's basically, it's called as a message record, okay, or equivalent use of message and the event. Okay, a record in a Kafka consists of metadata and a body. Okay, metadata contains the timestamp or the message details. Basically, I can say it can contain the message number, the magic byte, the timestamp, and few of the headers like where it came from, what time it is. Okay, so these are all optional data. If we want, we can incorporate, or else we can just go with key value pair. Okay, the value part is very important because it contains the actual business relevant data. Okay, the key by default is used to decide into which partition it has to go or which consumer it has to pick it up. Okay, this is basically used for the downstream processing, since ordering of the messages are not guaranteed in this distributed model. Okay, all right, so let's go to the next one. Okay, offset. Consumer offset is very important concept in here. Okay, so each and every log or a message is given by a number. You can see it's termed as 0, 1, 2, 3, M1, M+1, M+2, etc. Right? So here, offset is a position within a partition, okay, for a next message to be sent to the consumer. Say, consumer is reading the message from 0 to 1 to 3, and this keeps a track of the messages where the consumer is reading. Okay, so there is two types of consumer offset that I could say. What's called current offset, okay, and a committed offset. So whenever a consumer read the message, say and say to broker saying, I have picked up the message, I have processed it, so mark it red. Okay, so we are marking it red. It's called as committed offset. Okay, right? Let me explain about the current offset. When we call a poll method, Kafka sends messages to us. Let us assume we have 100 records in the partition, right? The initial portion of the current offset is 0. Okay, we made our first call, received 20 messages. Okay, now Kafka will move to the current offset to 20. Okay, and when we mark our next request, it will read some more messages starting from 20. Okay, and again move the current offset forward. The offset is a simple integers actually that is used by Kafka to maintain the current position of the consumer. Say in this case on the diagram, it is offset equals to 3. And here the consumer 3 is running as offset equals M+1. And here the consumer 2 is reading at offset N+2. Okay. These are basically pointers out to the last record that the Kafka has already sent to the consumer in the most recent poll. So the consumer does not get the same record twice because of the current offset or the committed offset. Okay. All right. So let's go forward to the next slide. Okay. So here is a more interesting part. So I'll be showing you how the data is being processed. Okay. Let me know if you're seeing the screen. Are you able to see my screen? Still,
No, sir. Your screen is not visible. You first need to unshare this first screen, sir.
okay, one moment.
Then you share the demo part.
All right, yeah. Okay. Can I share my whole desktop?
Yes, sir. But just you unshare the previous part, previous slides.
Okay.
Yes, sir. Now it's
Okay,
visible. Now it's visible, sir.
are you able to see it, right? Okay.
Yes.
So I'm running a simple Ubuntu machine. Okay.
Okay, sir.
So this is part of demo. Okay. So this is a simple Ubuntu machine which is running on our laptop. Okay.
Sorry to interrupt you, sir. Can you please increase the font size of the screen?
All right. Yeah.
Just
Okay.
is it full screen, sir?
Yes. Yes. Are you able to see it now? Is it okay?
It's okay, sir. You can proceed.
Is it okay now?
Yeah, it's okay, sir. You may proceed.
Okay. It's quite difficult because I'm using larger
Not a
systems.
problem, sir. Not a
Okay. All right. So I hope everybody knows about Linux. So here I have a directory called opt vcs Kafka. So inside that I have uh, what I can say is I have this software which I've downloaded. Okay. So I'm going to untar it. Okay. So this is how you untar the system. All right. And to proceed forward, I'll be running few of the commands to basically set the cluster up. So while we do it, we need Zookeeper and Kafka broker, right? So Zookeeper monitors the Kafka broker, right? So I'm going to set up the Kafka broker first. All right. So I'll be creating few directories and linking it them. Okay. So this seemed to be untarred. So I'm making a copy of it. Okay. All right. So I'm going to paste these commands in here. So this will help me to set up the cluster. Okay. Now I have created the directories and where with the software extracted in it. Okay. And now I'll be configuring Zookeeper. Okay. So let me see my profile is set up. Oh, yes, perfect. My profile has been set up. Source echo dollar confluent underscore home. Okay, you can see it in here. Okay, to start with, I'll be configuring few of the directories and copying the default properties and starting it. All right, so I've copied these properties in here. Let me go to these properties to enable it. Okay, so you can see a few properties called client properties that which needs to be enabled, right? And this should be enough like to make a cluster. All right. And I'll be creating a small shell script to, to start these components. Okay, I've already written these scripts, so I'll be copying it directly to the cluster. Okay, so let's say cat setke.sh, and I'm going to paste it. Okay, I'll change the mod to 7.5. This is basically execute permission. Let me check if this is executable. Yes, it's executable. So I'm going to start these component. Say start. So you can see it's getting started. And yes, so this component is up without running. Okay, so this is basically to manage the Kafka broker, right? So this is the first component that we need to have it in our servers. Okay. Okay, so now I'll be creating another directories and property file for the Kafka broker. Okay, so let me get into this VI server properties. Okay, so in this properties, so I'll be mentioning my listener. Okay, so where I have to listen to, because the producers will be configured based on the listeners. Okay, so I'll be listening as plain text data, and I'll be inserting the server IP. It's not copied, so let me copy it again. Copy. So I'll go to the listener, paste it. Okay, so this is where I can listen to. Okay, this is 9092 port where my producers and consumer will be listening. Okay, and then let me connect this to the zookeeper, because this is where my data will be stored. This is the log directories. This basically stores the topic, and it will store the segments. I can show you that. Okay, and there are a few other properties which are quite advanced, so which I'll not be covering in this session, because this is not meant for the advanced topics. So the zookeeper is also running on, oh no. Okay, so here is our property. So I'm adding the IP address of my hostname. Okay. All right. So we have the property files ready. So let's have a small script to start the component. Okay. Just like how I have Zookeeper, I have written a small script for the Kafka broker as well. Let me change the permission. Okay, so once I changed, let me see the logs, whether my data is completely started. Okay, wonderful. So I can see my component has started, Zookeeper and the Kafka broker, right? Let's wait for a moment to just start it. All right, wonderful. So we can see the Kafka broker being started in here. Now, how do I create the data for a topic? Okay, how do I create uh, the topic for the data, sorry. So Kafka topics, I'll mention hyphen zookeeper. Let me record the IP address so that we have to use it everywhere. So let me list down Kafka topics, hyphen zookeeper. So 10.0.2.15.2181. Let me list if there is any existing topic in here. Yes, I could see two system topics. Let me create a Kafka topic for us. Okay, Kafka topics hyphen create hyphen bootstrap hyphen server. So this is a command that which we create topic. It reasons on 9092 hyphen topic. Say session hyphen JSS. Okay, and say hyphen partition. Say one hyphen replication under fun factor. As I'm having only one broker, so I'm just creating one replication factor. Okay, bootstrap server is not recognizable. Okay, let me see what is there. So when you enter a plain command, it shows you what all options that you can use it. So let me go and see what is there. Bootstrap server, hyphen bootstrap server. Okay. So let me put this at the back, bootstrap server, say hyphen create. Okay, sorry, my boot, sorry about the spelling. Okay, so finally we got the topic in here. Okay, so let me introduce a new tab so that we can see the producers and consumer to the data. Okay, so there's two ways of producing data to Kafka. One is through any of the application, other through CLI. Okay, so I'm using CLI for now, so that console producer. Okay, so how we produce the data. So I'll be producing text data into this topics. To go, I think I missed something in this. So if I want to say um, any type of data can be produced and consumed. Okay, there's no specific type of data that you need to use. Okay, so hyphen bootstrap uh, hyphen server 10.0.2.15 colon 9092 say hyphen topic session hyphen JSS, right? You can see my console consumer, console producer has started. Say hi, this is my first message, okay, for the session. All right, I'll press enter. That means it has successfully posted to topic. Then I'll just say second message, third message. All right, and I cut this and say uh, there's so many things. It has read 3 messages at a time. Okay. Now what I'll do is I'll read the messages using console consumer hyphen hyphen bootstrap hyphen server 10.0.2.15 9092 hyphen hyphen topic session GSS. Okay. Here, oh no, bootstrap. Okay, the spelling mistakes are again. Sorry for the typo. Here, you noticed the consumer is not able to consume the messages because it has resumed from the last message. So we have to tell the consumer that you need to start from the beginning. Okay. All right. So now you can see the message being consumed, right? Now on the parallel side, I'll be producing the data and you can see the data being consumed on the other side. Server 10.0.2.15.092 hyphen hyphen topic session hyphen JSS. Okay. All right, my producer is started. I'll just say fourth message. Let me open it parallelly so that you can see it, right? Are you able to see both the terminals, right? Please let me know if you are not able to see it so that I can change. So I'm pasting it. Okay. So on the top, you can see my producer, and the bottom you can see my consumer. Okay. So the consumer has finished reading the third message, so I'll read the fourth message, right? So you can see fifth message. I can be typing any format, any of the special characters as well. So there's no specific thing. It can be reading continuously, right? So this is basically to show the producers and the consumer, right? All right. So let's get into the data store. Okay. So I was showing about the topics, partitions, and segment, right? Now let me go to the data store where the data is stored exactly. So you can see the consumer offset where the message is being stored. Message number is going to be stored. So this is our topic with one partition. Okay, so inside this, you can see the time index and the segments. These are the segments inside this, right? So if you see, this is the topic name. This -0 is the partition, and this is my segment. So you have two segments. That is, one is time index, and one is the data index and the log. Okay, and here is the checkpoint where the data is being written. Okay. All right, so this is the small demo that I had. If we want, we can have a in-depth session later after this session, all right, if time permits. All right, so let me go to the presentation again. I hope everybody understood the small session of the Kafka and the distributed platform, right? So I want to show you a bit more. I wanted to show you the real-time presentation of how real-time application of this Kafka. Okay, so here you see this real-world use case. This is the ecosystem built in Uber. Okay, you can see rider app, driver app, API services, map services, as everything is integrated to Kafka. So these are basically at the cab side, which has these services sending data to Kafka, and this is the processing system which consumes the data, and it'll send to the data consumers, that is basically the users of that application. Okay, so you can see the mobile data app and debugging, and you can see real-time alerts and movement of the cab, and you can see the alerts and the dashboard, like your historical uh, bookings and trips and all these things. And there is another called batch pipeline, which is integrated to the big data systems, where it stores the data, and it is applicable for machine learning and AI. Okay, this is a small use case. It's a real world use case, and this one it's this may not be the exact architecture. This may be a high level architecture of that application. Okay, and other real world use case like Hotstar. Okay, so here the content, okay, is very important. So the contents are stored in Amazon S3. Let me go through the components first, and then you can discuss more about it. This is Amazon. I hope you're familiar with AWS, Amazon Web Services. Okay, they provide services of various components. Okay, so this is Amazon S3, and this is a map reducer. Okay, and this is Python applications, and this is again client applications which connects to the mobile, and it'll show you the data. Okay, this is Golang service. This is an API which is built on Golang. Golang is a Google's programming language. Okay, so say suppose our Hotstar client application, which is installed on our mobiles, makes a request to this app which is running on some server, makes a query to Kafka. Kafka will read the content from Amazon S3. Okay, so our video files, data files, streaming files are stored in this Amazon S3. Okay, so it establishes connection to Amazon S3, make a map reducer. Map reducer basically compress your data into smaller chunks, which is easy to transfer, right? Otherwise, your mobile data will be consumed a lot, and you may reach your daily limit. Okay, so this make a compression of the data, send it to Kafka, and there's a Python libraries which takes this data to your mobile and decompress it, and shows it to you on your mobile app. Okay, so this is another real world application which uses Apache Kafka. All right, thank you. That's all I had for this presentation. Thank you, and these are my details. You can connect to me via this email ID. All right. Thank you, guys, and if you have any questions, I'm open to answer.
Thank you, sir. Thank you.
Thank you.
So I would like to take a few questions. First question from Shilpi Bansal. What is the difference? What is the difference between Hadoop and Kafka?
Yeah, nice question. Yes, Hadoop stores the data and does not process it. Okay, it stores the data for later purposes as well, and it can store the data of large extent. Okay, basically it does not have any retention period. Okay, Kafka is a messaging, so it stores the data for a certain period of time to process real time. Okay, and for Hadoop, if we want to read the data from Hadoop, it takes a long time. You need to have special libraries for it, right? For Kafka, you don't have a specific libraries you need. You can use native libraries and just query Kafka and get the data. Okay. Basically, I want to say is Kafka retention period is 7 days, and Hadoop can store the data for longer time. Okay, and they're used for machine learning and later purposes as well. Okay.
So next question from Jyoti Sehgal.
Mhm.
She is asking, on what basis partition done in Kafka cluster?
Yes, that's a nice question, Jyoti. So partitions are done based on the number of consumers to enable parallelisms. Okay, say I have one topic which is has sending like hundreds and millions of messages, right? And I have only two consumers, right? So to enable parallelism, I'll enable only two partitions. Okay, so if I enable more than two partitions, so that remains idle and the storage is of unused, and it's a cost to the company, right? So based on the number of consumers and high availability, we will decide the number of partitions for the topic, right?
Next question from Dr. Indrani Saha.
Mm-hmm.
She's saying, can we apply Kafka in a big multiple shops like Big Bazaar and all?
Yes, why not? Why not? I think they are already applying it. Okay, so basically, in shipping or receiving the what you can say the materials or items, the shipping companies will be using it. Yeah, we can use it, but you need to have a particular use case for it. Yeah.
Next question from Santosh Kumar Upadha.
Mm-hmm.
He's asking how Twitter uses Kafka. How can we process streaming data in Kafka?
Yeah, Twitter, just like Hotstar and Uber, they are using it. And I haven't gone through this all the architectures yet. So they're using it. LinkedIn is using it. Twitter is using it, and a few big companies like Kongsberg and payment gateways like Visa, Mastercard, Verifone, and our e-commerce PayPal. Everybody is using Kafka. Yeah, in that case. Okay. So Twitter, in that case, Twitter has lots of feed data that is coming in. I hope they should be using it, and I haven't explored Twitter yet. Yeah.
Okay, sir. Last, one more question
Mm-hmm.
from Shabi Fatima.
Mm-hmm.
She's asking, how can we sure about Kafka's reliability?
Yes, wonderful question. Yes, Kafka reliability is, you can see the messages going into a particular topic, right? And it is storing in partition, right? So this partition is replicated onto a different server, right? As I showed in the presentation, right? Let me show it to you again. Are you able to see my presentation, right?
Yes, sir. Yes, sir. It's visible.
Okay. Let me see. Okay. If you see in here, right? So a data or a producer sending data to partition 0, it makes a copy to the broker 101, 102. Okay. So if broker 101 fails, broker 102 has the data and it can serve the consumer, right? So this basically depends on the replication factor. So replication, I think here it is 3. So 3 copies of data are available in the Kafka cluster. So even though here, if 2 brokers goes down, and you can see at least you'll have 1 copy of data available, right? So here, the reliability of the data which is there in Kafka brokers is 100%, right? Okay. And there is another thing, like when a producer is producing data to Kafka, there is acknowledgement modes. Okay. So there are many delivery semantics as well. That is quite in depth of the session. It takes a lot of time to understanding. So that's why I haven't included in this presentation. Yeah. Maybe in the next session or something, if it is scheduled, we can discuss more in depth of it.
Sure, sir. Sure.
Yeah.
So I would request rest of the participants to kindly inbox your queries in our experts email ID, because as we have limited time. So finally, I would like to thank you so much, sir, for sharing so much of information in a very limited or short span of time, as this topic seems very vast. So
Yes, yeah.
thank you so much, sir. Now I would like to invite our HOD to say a few words.
Thank you.
Thank you, sir.
Thank you, everyone. Yeah.
Over to
Nice
you,
talking.
sir. HOD, sir.
Thank you so much, ma'am. Can we end this poll, ma'am?
Yes. Thank you.
Suresh sir, can you please unshare your slide?
Yes, thank you very much. Yeah, I haven't shared my slide.
Being the convener of this program, Suresh sir, I really am blessed to have such core and technical person of the field, which really maximum, you can say, people of good organizations, or you can say who's working on a platform where they need not to put the servers at their end. We need not worry about the security issue, need not worry about the storage, need not worry about n number of things. And you have shown a very great and detailed description of it. We are really thankful to you in that way. Simply, many queries has been already been raised by many of our participants. What I feel like, sir, can you have a concept like of a, if I say that, for example, let's take in JSS Academy of Technical Education Noida, we do have servers at our end also. So if we have need to have the server of, you can say Kafka, then is it as you have shown in your slide also that replications takes place if you have a maximum number of replicas, or as per the requirement replicas can be there. So
Yeah,
do we need to have the same concept as we have a servers blade system we have in the servers?
Yeah, we can have, depends on your application, sir. So how you are architecting, how you're building, and what that application serves. So based on that, we can talk about it and see about it, because here the data is retended only for 7 days.
So how can we improve it? Is it possible to extend for some more time? Because being if we want to have the server on this platform, then I think it will be a little costly to have only for 7 days. That's what I believe.
Yes, first I need to know like what is your use case. So based on that, we can try implementing it.
Yeah, use case can be, sir, can be in, you can say at a small scale also, or it can be large scale also.
Yes. You can run on, see, there is no minimum requirement of hardware.
Okay.
So it depends on your capacity. Okay. So I am running this virtual machine on my laptop, which has 16 GB RAM and 250 GB hard drive. Okay. So there is nothing, you can run it on your machine. There's no minimum requirement and depends on your data. Okay. So we are running in our organization, I'm running a data structure of like 5 to 6 TB of data, which is coming in. Okay. So let me give you an example of the environment which I work, right?
Yeah.
So everybody has these debit cards, right? Debit cards and credit cards, right?
Yeah.
So if you see in one city or a town, we can have n number of swipes at a particular time, right? Everybody goes out for shopping, they swipe the card everywhere, right?
Yeah.
So this data is from the terminal, it's sent to various systems, right, at the background for processing, right? So this data is very critical for us because it's a financial data. So it's so reliable to use Kafka so that we don't miss any of this transaction, right? So if I miss one transaction, it's very costly for the application owners or the company, right? So we are handling such a data so that we are not going to miss each and every transaction, right? So that's why we are using Kafka and 7 days of data retention, and it can be increased. And if you see per second, we are managing up to 10,000 requests per second. Okay, so we are running big clusters. Okay, yeah. So it's good. Even at the educational institution can run it, but you can use from minimum hardware. There is no minimum requirements for this software to be used, and you can see if you have some use cases you can implement and in as a project in your college or the academy.
Okay, okay. That means it's for a short span of time. If you want to have something which is of higher security, and then
Yep.
you can transfer it to some other secondary devices. I mean to say that then it's really more helpful, I believe.
Yeah, I have one use case. Okay, so if you see, everybody has car insurance, right?
Yeah.
Right. So suppose a car is met with an accident, right? So and police comes to that location, he captures all the pictures and make a FIR, all these things to claim the insurance, right? So in the new generation, how it happens is everybody will be getting their insurance policy on your mobile, right? This mobile app can capture the data of your car. It can capture the photo of your car. Okay, send the JPEG files or PNG files to Kafka. Okay, where it stores for certain period of time, and another application which can read these pictures, analyze the impact, and give you the claim immediately. Right, it can be done. Right, but in our current situation, you need to file a FIR, you need to take pictures, take a printout, file it to the insurance, and insurance comes like 1 month later, right? By the time your car is fixed, right? So there is a real case scenario where you can use mobile apps for this as well. Okay.
That means the transfer rate is a little faster as compared to the other
Yes,
cases.
yes. So as and when you take the picture, there will be a program which will be reading called image processing. This is all machine learning concepts, where you can process the image, you can analyze the impact and transfer your claims based on that.
That's true. That's true. So thank you so much, Mr. Suresh.
Yeah.
Like
Yeah.
really, I'm very helpful and thankful rather from the bottom of my heart, as well as from the organization, from the management side of JSS Academy of Technical Education, Noida, to had such a great personality today in our session. And all the participants has already shown a keen interest and given the good you can say comments, as well as they have gone good queries they have issued raised also. So that proves really that the session was very informative, and all the participants were intact and were listening to you with their full enthusiasm. So
Yeah.
I'm really feeling blessed, and would definitely feel that we'll have one more session with you sometime as a
Sure,
webinar,
sir.
so that we have detailed so that we can even install at our end, and so that you can hands on to us, so that we can install
Sure.
it and small programming into it and get the things done.
Yes,
Because
sure, sure.
you have so many of good students that keep doing their live projects, and they can be helpful in some or the other way to us.
Yes, sir. Sure, sure. Definitely. I'll be blessed to help you guys out,
Yeah.
and I can share what are my learnings as well,
Yeah,
not only to the organization but to the academy as well. Right.
that's true. Thank you so much, and I'm
Thank you.
also thankful to our coordinator, Mr. Hanumant Rao, who has suggested such a great personality today for the session. Thank you so much, Mr. Rao, sir. He is already there live with us. Thank you so much for the session, and thank you all the participants once again to have such a personality, and you have interacted with them, keeping in touch with them, and very informatively you were listening to them, raising your queries. Thank you so much, everyone. Thank you, Tara ma'am, for giving me the opportunity to speak for such a personality today, and holding the session for the entire day. Thank you so much. Have a great day, everyone. Sir. Thank you so much, Suresh, sir.
Thank you. Thank you very much. Bye.
So we formally end the session, sir, today.
Yeah, sir. Yeah, ma'am. You can formally end with the participants. We can say that tomorrow again we will be live from 9:30 a.m. and I'll forward the day 4. You can say participation or invite to everyone, so that they can proceed for the registration process for the day 4. Thank you so much.
Thank you so much, sir. Thank you.
Thank you, sir.